sorry that it has given me an error, but let me start all over again by typing our command, starting from summarize income, then comma, space, detail, then press enter. As you can see, it has given us the summary of income, which is showing percentiles, smallest, largest, and then number of observations, and mean, standard deviation, variance, and the like. So for us to deal with these outliers, what do we normally do? We have to type drop, then space, if, space, income, comma, is greater than or equal to 400,000, then press enter. As you can see, it has given us two observations that have been graded because they were our outliers. Let us proceed to our next task, which is to check if they are duplicates. So let us type duplicates list. That's the command that we can use to check if they are duplicates. As soon as you type this, then you can press enter, and it gives you the number of duplicates that you have. As you can see here, we have 1, we have 1 and 1, 2 and 2, 3 and 3, 4 and 4. So these are our duplicates. So how do we deal with duplicates? Or what we need to do is to type duplicates drop and then press enter. From the results that we have been given in Stata, it looks like we had 4 observations that were deleted. So let us proceed to our next task, which is to summarize all our variables. So how do we summarize all our variables? First thing is to type summary, summarize, then you can group your variables starting with age, education, experience, then income, then press enter. As you can see, it has summarized our variables. From there, lastly, we have to type another command for us to run the analysis. So it is regress all our variables starting from age, and then education in years, experience in years, as well as income, and then press enter. This is the summary of our analysis. Let me just interpret the results that we have here. The results that we have here is showing that the model is significant looking at probability, which is 0.0000. it means that our model is significant. Looking at our R square, which is 0.9796, it basically means that 97.96% of the variation is explaining dependent variables, which are education, age, as well as experience. Let me proceed to our coefficients. Our first coefficient, as you can see, it is 0.1334099. Well, proceeding with our interpretation, as you can see, the results that we have here after running the analysis, it is showing that we have the probability of 0.0000, which is less than 0.05. That means that the model is highly significant. If we look at goodness of fit, which is R squared, which is 0.9796, this means that 97.96% of the variation in the dependent variable is explained by education, experience, as well as income. Proceeding to our coefficients, we can see that education is giving us 0.1334, which interprets each additional year of education is associated with an increase of 0.133 units in the dependent variable, holding other factors constant, or I should say ceteris paribus. Proceeding to our second variable, which is experience in years, it is showing us that we have the results of 0.9511. That means each additional year of work experience increases the dependent variable by 0.951 units, ceteris paribus. Let us proceed to income, of which it has shown us that it is 0.000191. This means for each unit increase in income, the dependent variable increases by a very small amount, which is 0.0000191 units. This is expected if income is measured in large units like Malawi Kwacha. Looking at constant, which is our intercept, it has given us 17.2788. That means when education, experience, and income all zero, the model predicts a baseline value of 17.28 for the dependent variable. Thanks for watching. This marks the end of our lesson.